A previous video talked about what a basic limit was. Now we want to finish kind of this section of James Stewart's calculus book by talking about the difference between a right-hand limit and a left-hand limit. Well, let's start with an illustration of a certain kind of function. The Heaviside function h is a kind of a strange function to me, maybe not to you. But basically, for the Heaviside function, the value of the function is 0 if t is less than 0, but it's 1 if t is greater than or equal to 0. So it's basically an on-off kind of situation. If t is less than 0, it's off. If t is greater than 0, it's 1. Okay, there you have it. So the limit, basically, now let's talk about limits. As you approach this from the negative direction, as you approach this from the left, as it were, you have a different limit, because the limit as you approach from the left is 0. But the limit as you approach from the positive direction is 1. And so you basically have different limits at the same point. When you get to 0, you have one limit approaching from the left and another limit approaching from the right. Basically, this function illustrates the fact that in some cases, the limit as you approach from a different direction, positive or negative, can come to a different number at the same basic spot. So, a left-hand limit is the limit as you come from the negative or left side, as we normally graph these sorts of things. So you say that the limit as x approaches a from the negative side of f of x is a certain thing, L. So you see this little negative by the a. That means you're approaching it from the negative direction, from the left side. And we read this in this way. The left-hand limit of f of x as x approaches a is L. Okay? So you can also have then a right-hand limit. This is the limit as you come from the positive or right side in the way we normally label these things. So the limit as x approaches a from the positive side of f of x is L. And we read it, the right-hand limit of f of x as x approaches a is L. Okay, not too hard, just a question of where it's going depending on which side you come from. Now, when we say the limit as x approaches a is L, if we don't specify right or left hand, then we are implying that it approaches the same number from both the right and the left. Okay, so if we just say as x approaches a, the limit is L, we are assuming that both the left-hand limit and the right-hand limit are going to be exactly the same. That the L in both cases is going to be the same. Okay. Now there are infinite limits. This would be the limit as x approaches a, f of x approaches infinity. And usually you're going to have what's called an asymptote. An asymptote is an imaginary line that the function never gets to, but gets closer and closer to. So if the limit as x approaches a, goes up to infinity, then there's an imaginary dotted asymptote there, that basically says, do not come here. You can approach, but never get here. So we would say that the limit as x approaches a in that case is infinity. And you can also have the same thing can happen negatively. As x approaches a, it can go to negative infinity. And again, you'll have a vertical asymptote there, an imaginary dotted line that says you cannot cross this line, or you cannot get to this line. There may be something on the other side of the line in some cases, but okay. So these vertical asymptotes. How do we know that we have a vertical asymptote? If any of the following are true, then you have a vertical asymptote. So if the limit as x approaches a equals infinity, or if the limit as x approaches a is negative infinity, you have an asymptote. Or if the limit as x approaches a from the left-hand side approaches infinity, or if the limit as x approaches a from the right-hand side approaches negative infinity, from the left-hand side approaches either infinity or negative infinity, you have a vertical asymptote. And then as you come from the right-hand side, if it approaches infinity or negative infinity, you have a vertical asymptote. So a little bit about right-hand and left-handed limits, as well as infinite limits and asymptotes.